In today's video, we are going to be discussing ethers. Now here we have the outline of what we'll be discussing. What are ethers, naming of ethers, isomerism, and synthesis of ethers. Now in our video on alcohols, we discussed that there are two types of organic compounds with a single bonded oxygen atom that looks like this. And we said these two groups of organic compounds are alcohols and ethers. Now, alcohols have the oxygen atom bonded to a carbon on one hand and a hydrogen atom on the other hand. And of course, the OH here, which is the hydroxyl group, is the functional group of the alcohol. Now, for ethers, it's the single bonded oxygen is bonded to carbon on another hand and another carbon on the other hand. This is the major difference between an ether and an alcohol. Now, of course, the ether forms a homologous series of compounds, and the general representation of its molecular formula is R bonded to oxygen atom with R on the other side. Now, R here, of course, represents an alkyl group. Okay, so if we are to represent this with a molecular formula, we can represent it as CnH2n plus 1, which represents an alkyl group bonded to oxygen with another alkyl group on the other side that looks like this. Okay, this is the general representation of the formula. However, a simplified molecular formula for the ether rather, would be CnH2n plus 2O. Okay, this is the general molecular formula for an ether. Now, the way in which the alkyl groups would be arranged depends on the value of n. Now, of course, n has to be a number above 1, so we can have two alkyl groups. So n can be n equals 2. In the case where we have n equals 2, we would have C2H6O. Okay, now we can have, this means that we can have two methyl groups on either side of the oxygen atoms. Okay, so we can have CH3 on one side bonded to oxygen and CH3 on the other side. Of course, this gives us a C2H6O. This is what an ether is. This is the general explanation for what an ether is. Now let's move on to the naming of ethers. Now, having looked at the general representation of an ether, which is R, O, R, like this. Now, R, of course, as we know, represents an alkyl group. Now, these two alkyl groups, R1 and R2, could be the same. So, R1 and R2 could be the same alkyl group, or they could be different alkyl groups. Now, in a case where we have R1 and R2 to be the same, then we would name this ether okay, let's first take a look at a situation where they are not the same. Now, in a situation where R1 and R2 are not identical, we are going to consider the shorter alkyl group. Okay, consider the shorter alkyl group. So if the shorter alkyl group, for example, is ethyl, then we'd name the shorter alkyl group as an alkoxy. Okay, now this simply means that ethyl would have the name ethoxy. Now, if the longer alkyl group in this case is propyl, then we would name the longer alkyl group as an alkane. Okay, so it would have the name propane. And would name this compound ethoxy propane in this way. Okay, now a common name for this would be that we would consider each of the alkyl group as they are. We won't represent one as an alkoxy and another as an alkane. Okay, we would represent them as alkyls that they are. So in this case, this compound would be named ethyl propyl ether. Okay, this is to represent that the compound is an ether. Now, in a case where R1 and R2 are the same alkyl groups, then take for instance, R1 and R2 are both methyl, then the compound would be named dimethyl ether, or in short, in general rather, it would be named dialkyl ether. And in a case where we have different alkyl groups, the general name would be alkoxy alkene. Okay, this is how an ether is named. So to re-emphasize it, first you start by considering the shorter alkyl group, okay, and we'll name the shorter alkyl group as an alkoxy. Then we consider the longer alkyl group and we name it as an alkane. Okay, so in this case we have alkoxy, or rather we have ethoxypropane. Okay, now let's take a look at isomerism in ethers. Ethers exhibit two types of isomerism. We have functional isomerism, okay, functional isomerism, and positional isomerism. Now, functional isomerism has to do with the existence of compounds with the same molecular formula but different with the same molecular formula but different homologous series. So these compounds have the same molecular formula, however, they belong to different homologous series. Now, ethers exhibit functional isomerism with alcohols. Okay, so alcohols, for a given ether, you could have a corresponding alcohol with the same molecular formula. Now let's take a look at C at n equals 2. Okay, for n equals 2, of course we have general representation for the ether to be CnH2n plus 2O. Okay, so we can have methyl on both on either side. Okay, so this is C2H6O and we can have CH3OCH3. Now the representation for an alcohol is CnH2n plus 1OH. Okay, so we have ROH basically, which is the representation for an alcohol. Now, when n equals 2, we're going to have C2H5OH. However, notice that although we have 5 hydrogen atoms on this side, we also have another hydrogen atom on the other side in the hydroxyl group. So in total, we have 6 hydrogen atoms and 2 carbon, 1 oxygen. Okay, so this is C2H6O. Now notice that this is the same formula that we have for the ether on this side. So simply put, ethers exhibit functional isomerism with alcohols, and this is because we can have an ether and an alcohol with the same molecular formula, but of course they belong to different homologous series. Now let's take a look at positional isomerism. Positional isomerism has to do with the existence of isomers which have varying positions of the functional group. So for a given molecule. Okay, if we have a situation whereby the functional groups occupy different positions in the carbon chain, then we have a positional isomer. Now, for this, we would be considering when n equals 4, such that we have C4H10O. Okay, now in this case, we have 4 carbon atoms. So it means that we can have a 1 carbon alkyl and a 3 carbon alkyl. 1, 3. Also, it means we can have a 2 carbon alkyl on one hand and another 2 carbon alkyl on the other hand. Okay, and the third case is for us to have a 1 carbon alkyl and a 3 carbon alkyl. But we already know from our first video that alkyls starting from n equals 3 actually exhibit isomerism. So for propyl, for example, we have propyl and we have isopropyl. So let's take a look at this. Okay, having 1 3, so we have methyl, which is CH3O attached to C3H7. Okay, this is one alkyl with this general molecular formula. Notice we have 4 carbon atoms and 10 hydrogen atoms with 1 oxygen atom. Okay, this is an example, and this would have the name methoxypropane. Okay, now in a situation where we have two carbon alkyls on either side, would have something that looks like this. So we'd have C2H5O and C2H5O. Okay, so in this case, we have an ethyl on this side and we have an ethyl on the other side. Okay, so we can consider any of them to be the longer chain. Considering any of them to be the longer alkyl chain, we take ethoxy ethane, or we can also name it diethyl ether. And of course, this can be named methyl propyl ether. Now, just to remind us of the different isomers of the alkyl propyl. So propyl is represented, or rather propyl of course is derived from propane, and propane has the formula C3H8. Okay, so something that looks like this. So we have 3 carbon atoms and the hydrogen atoms attached in this manner. Okay, 2, 5, 6, 7, and then 8. Now, the carbon atoms highlighted in green have hydrogen atoms that are equivalent. So the hydrogen atoms attached to the carbon atoms highlighted in green are equivalent. So if any of these hydrogen atom is removed to form an alkyl, okay, if any one of the hydrogen atom is removed to form an alkyl, the alkyl that would be formed would be propyl. Okay, so if this hydrogen atom is removed, then we would have something that looks like CH2, okay, CH2, CH3. Now this alkyl is a propyl. However, the carbon atom highlighted in yellow, okay, this particular carbon atom has hydrogen atoms that are in a different environment from the 6 other hydrogen atoms. So if the hydrogen atom is removed from this particular carbon atom, if either one of these hydrogen atoms highlighted in yellow is removed to form an alkyl, the alkyl that would be formed would be isopropyl. Okay, so now we want to consider a situation whereby the 1,3, okay, is a methyl and an isopropyl. Okay, so let's take a look at that. Okay, so we want an isopropyl. Now we're going to have something like this. So CH3, CH, CH3. Okay, and then we're going to have the alkoxy group attached in this manner. Now notice that we have 10 hydrogen atoms, as in C4H10O, and we have 4 carbon atoms. Now this alkyl group is not a propyl, it's an isopropyl, and this ether would be named 2-methoxypropane. 2-methoxypropane because the shorter alkyl group, which is this, the shorter alkyl group is not attached to the longer carbon chain directly, okay? Rather, it's attached to the second carbon atom of the propane, and that's why we have 2-methoxypropane. Now, the common name for this would be methyl isopropyl or isopropyl methyl. Now notice that in the 3 isomers that we had, that is C3, or rather CH3O, CH, C3H7, and C2H5O, C2H5. Notice that in these 3 isomers, 1, 2, and 3, what has changed is simply the position of the functional group, which is a single bonded oxygen atom. This is what has changed in these 3 molecules. However, these 3 molecules are all ethers, meaning that they all belong to the homologous series of ethers. They all have the same functional group. However, the position of the single bonded oxygen atom has changed. Okay, this is why these 3 molecules are referred to as positional isomers. Also notice that they have the same molecular formula, which is C4H10O in all 3 cases. Okay, so this is all about functional isomerism and positional isomerism. Now let's take a look at the synthesis of ethers. Ethers are formed by the dehydration of 2 molecules of alcohol. Okay, so let's take the alcohol methanol. Methanol has the formula CH3OH. Okay, so let's draw out the structure this way. Okay, OH, this manner. And we have the other molecule this way, H, H, and H. Now the dehydration, of course, is the removal of a water molecule. Now the water molecule is removed as 1 hydrogen is removed from a molecule of one of the alcohols, and an OH, or the hydroxyl group, is removed from the other molecule. So a water molecule is removed in this way, and of course would be left with this part and this part, which combine to form an ether. Okay, that looks like this. Okay, let me just take this out. Okay, so we have this part CH. This is what is left of the alcohol in green. Okay, and of course the oxygen atom, and for the alcohol in blue, this is what is left. Okay, so we can see that we have formed an ether which has the name methoxymethane or dimethyl ether. This is how the ether is synthesized. Now we have come to the end of this video. If you liked this video, please give it a thumbs up and kindly subscribe. Thank you.